Hello everyone, welcome to Electronically Connected. In this video, we will be moving forward with the topic of K-map, and in this video, we will be covering the K-map for 4 variables and 5 variables, and we'll see how it can be used for further simplification. So let's get started. So the K-map for 4 variables have 16 cells because 2 raised to n, that is 4, so we have 16. Also, the 16 cells represents the 16 combinations that can be used as my input when solving a question. So let's see how the K-map is going to look like when dealing with 16 cells. So here we have our 16 cells with A, B, C, D as our variables. So on the left hand side we have A and B, which can be 0, 0, 0, 1, 1, 1, 1, 0 following the gray code. Also CD can range as 0, 0, 0, 1, 1, 1 and 1, 0. Let's see what each cell represents. So the first block is M0, M1, M2, M3. Then we have M4. So here we have our 16 combinations of our 16 terms that can be used in 4 variables. So each term represents each number, that is 0, 1, 2, 3 ranging to 15. So 16 combinations. Now again, here the grouping is possible between different adjacent cells, which can range from its individual terms to the pair of 2s, 2 ones, pair of 4 ones, pair of 8 ones, and the maximum can go to pair of 16 ones. That means the whole K-map altogether. These grouping will help us for further simplification. So let's understand this with an example. And here we will be taking an example of the pause where my each number, for example, it's 0, 1, 3. So each number will be represented with a 0 in my K-map, and we will be grouping my zeros because we are dealing with pause. That is the product of sums, which has the max terms. So my example is for the 4 variables A, B, C, D. The output is a product of the max terms. So let's substitute a 0 in all these terms. So we have 0, 1, 4, 5, 7, 10 and 15. So here we have our zeros. Let's skip on the 1 so that we don't get into confusion. Let's start grouping these. So we will start from the highest power, that is 16, which is not possible here. The group of 8 zeros, which is not possible again. Then we come to group of 4 zeros. Here we have 4 zeros which can be paired together. So here we have group 1, and then we have group 2. These two can be grouped together, so we have group 3. And then this is another group which can be formed, which is the group 4. Now we will be calling this as a redundant group because the 0 over here and this 0, the 0, 1, 0 and the 0, 1, 1, 0 is already included in a pair before, hence this is a redundant pair. So we will be skipping on this pair. So let's see what does the first pair give us. So we have again the common terms. Let's write down 0, 0, 0, 0, then 0, 0, 0, 1, 0, 1, 0, 1 and 0, 1, 0, 0. So the common term that we have is the A, B, C. So because this is pause, remember my first term will look like A plus C. Next, moving forward, we will have this group, which is again 0, 1, 1, 1 and 1, 1, 1, 1. So here what we have common is B, C, D. So we have B bar plus C bar plus D bar, because in pause form my 1 is equal to C bar. And next, for the third group, we have 0, 0, 1, 0 and then 1, 0, 1, 0. So what we have in common is B, C, D again. So we have B plus C bar because C is 1s and then D. This is the output that we get of the most minimized form of my Boolean expression, where first the number of terms which were possible were 1, 2, 3, 4, 5, 6, 7, 8. which came back to just 3 terms, and hence this is the most simplified form of my Boolean expression using a K-map for 4 variables. Next, let's look at the Boolean expression for 5 variables. So for 5 variables, let's understand what are the 5 combinations possible. So let's list some of them down. 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, and so on. And this can go to here. And then the next term will start varying from, again, 1, 0, 0, 0, 1, 0, 0, 0, 1. And this will go on to 1, 1, 1, 1, 1. So here we can see that my whole combinations, that is the 32 combinations, are split into 2 combinations of 16 each. So in this first 16 combination, we have A is equal to 0, and then the variations of B, C, D, E, and then A is equal to 1, and again the same combinations of B, C, D, E. So this will actually help us form 2 different kinds of our K-map of 4 variables each, with B, C, D, E and A is equal to 0, and again B, C, D, E combinations where A is equal to 1. So here my combinations, that is the terms, will occur from M0 to M15, and then the same here we have from M16 to M31. Hence all the 32 combinations possible, because for 5 variables 2 raised to 5 is equal to 32, that is 32 cells. So the combination of my 2 K-maps will give us 32 cells. So let's understand the solution of a 5 variable K-map with the help of an example. Now here we have, I'm again taking a SOP. So the terms that I have is, so this is the terms that are given to me, and now we have to use the K-map to solve this Boolean expression and get the simplified form. So let's draw my 2 K-maps when A is equal to 0 and when A is equal to 1 with the same combinations. So here we have the K-map for 2 different combinations of A, where A is equal to 0 and where A is equal to 1. So the first K-map is for 0 to 15 terms, and the next K-map is for 16 to 31 terms. So let's map this. So we have 0, 2, 4, 6, 9 and 13, and then we have our rest of our terms. So now let's start grouping them. So we have the very first group from these 2 ends on the first K-map, and then we have the second group. Now here again we have a group of 4 and a group of 2. Now what you have to be careful is, we can see that my second group here and my second group here is the same. Because these 2 groups are same, for this term we will be ignoring the term A. So let's see how this is going to be implemented. Let's write down for each term. So the group 1, we have Y is equal to, after simplification, let's try simplifying. So we have 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, and 0, 1, 0, 0. So what we have in common here is my B, C, D and then E. So because this is SOP form, so remember it's B bar dot E bar. And also remember this K-map is for A, 0, so A bar. Now let's leave this term for now. Let's go to the next K-map. These 4 terms, we have 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 0, 1 and then 1, 1, 1, 1. So now what are my common terms? We have C and E. So again A is equal to 1, so A dot C dot E. Now this is the remaining term. Let's calculate for the remaining term. We have 1, 1, 0, 1, 1, 0, 0, 1. What is common is B, C and E. So the same thing is going to happen over here. So we have 2 similar terms. But let's write that down to explain you what we're going to have. And again, same term is going to occur over here. Now let's write the respective A's. So for the first term, we're going to have A0, so A bar, and then we are going to have A. Now, because this term is same, we can still use the laws. So let's ignore the first two terms. What will happen is B d bar E and A plus A bar. Now what is A plus A bar, if you recall, is 0 plus 1. And what is 0 plus 1? It is equal to 1. So hence this is actually equal to 1. What is remaining is B d bar E. So to avoid this calculation, you have to remember, whenever my group is the same in both the K-maps, we will ignore the A or the variable that we are varying and just write the common terms. So my final answer is B bar, E bar A, ACE and B D bar E. So from all these terms which is possible, we just got 3 terms and hence the simplification. This was how we solved the 5 variables and 4 variables K-map. Thank you for watching. Please like, share and subscribe to my channel. Till then, happy learning. See you next time.